Hi guys, welcome back to our discussion on infinite series. In this video, we will discuss about the n-term test for divergence. According to Theorem 9.8, which is entitled Limit of the n-term of a convergence series, it says that if a sub n, where n is from 1 to infinity, converge, then the limits of a sub n is equal to 0 as n approaches infinity. The contrapositive of Theorem 9.8 provides a useful test for divergence. So this n-term test for divergence states that if the limit of the n-term of a series does not converge to 0, then the series must diverge. So, Theorem 9.9, which is entitled N-term test for divergence, states that if the limits of a sub n is not equal to 0 as n approaches infinity, then the summation of a sub n, where n is from 1 to infinity, diverge. So as an example, suppose you're given the series summation of 2 to the n, where n is from 0 to infinity. So to evaluate or to check whether this series converge or diverge, we have to evaluate the limits of the n term. Okay, the limits of 2 to the n as n approaches infinity is, this is equal to 2 to the infinity, where 2 raised to infinity is infinity, which indicates that because the limits is not equal to 0, so we can therefore conclude that this series diverge. Okay, another example, suppose you're given the series summation of n factorial over 2 times n factorial plus 1. So recall that to determine whether the given series converge or diverge using the n-term test for divergence, we have to evaluate the limits of this function, n factorial over 2 times n factorial plus 1. So to evaluate the limits of this function, we divide each term of the numerator and denominator by n factorial. So we get n factorial over n factorial all over 2n factorial over n factorial plus 1 over n factorial as n approaches infinity. But n factorial over n factorial is 1 and 2n factorial over n factorial is 2, plus you have 1 over n factorial. So if we replace n here by infinity, 1 over infinity factorial is equal to 0. And therefore, the limits, so this is 0. So therefore, the limits of this function, n factorial over 2n factorial plus 1, is equal to 1 half. And because the limit of the n term is not equal to 0, we can therefore conclude that the series diverge. Okay, another example, suppose you're given the summation of 1 over n, where n is from 1 to infinity. And to check whether this series converge or diverge, we have to evaluate the limits of the n term. The limit of 1 over n as n approaches infinity is equal to 1 over infinity, where 1 over infinity is 0. And because the limit of the n term is equal to 0, then we can therefore conclude that the n-term test for divergence does not apply, because if you can recall, the n-term test for divergence states that if the limits of a sub n is not equal to 0, so the series diverge. And because the limits of a sub n here is equal to 0, so we cannot draw any conclusion about the convergence or divergence of this given series. So in summary, if the summation of a sub n, where n is from 1 to infinity, converge, then the limits of a sub n, where n approaches infinity, is 0. And if the limits of a sub n is not equal to 0 as n approaches infinity, then the summation of a sub n diverge, where n is from 1 to infinity.